Hello everyone. Let's get started with an example for power unit system over here. So for this example, I have the circuit over here. You can see that I have a generator, then I have a transformer 1, transformer 2, and in between the two transformer, I have the line impedance Z. Then I have a motor connected at the end, right? So let me give you some details over here. For the generator, I have 80 megavolts amps. That's the generator rating, and or generator itself is the old base for the generator, and 100 kilovolts, and X is 10%, which means that it per unit impedance is only the reactive part of it. Impedance is, that means this one means that is 0.1 per unit, right? And over here it means that 0.15 per unit, and here also 0.15 per unit, and 0.08 per unit. So what this means over here, this is important to understand what is this over here. So it's saying that this per unit 1.5 per 0.1 per unit impedance was done based on this voltage, this MVA, and this voltage. All right. So based on this voltage that have 0.1 per unit impedance. All right. So now and same with the transformer 1, transformer 2 motors, and line has its own voltage and impedance over here. So now I'm bringing this to the power system, all those components, and comparing them or standardize them with the base. I have 100 MVA and 100 kilovolts at the generator end right here. So I'm using 100 kV volts at that point as my starting point. So first thing first, the 100 MVA base is for everything in the whole network, but your voltage could change along the system. So I have to make sure that I have the base voltage at every point. So base voltages. So let's say this is the point 1 here, this is the point 2 here, this is the point 3 here, this is the point 4 here, right? So VV1, as you know, that is 100 kVA, right? kV, not kVA, kV. And your point 2, I'm going to VV2 is 200 kilovolts, because they're the 1 to 2 ratio right here. You can see that 1 to 2 ratio for the transformer. And your VV3 at point is also 200 kV. I'm assuming that there's no loss in the line. And VV4 is 100 kV again. So now I have all those voltages at different points of the line. So now I have to make sure that whatever that old per unit impedance that should need to be transferred to the power system impedance, right? So as you know, the equation for this per unit new, if you remember, the equation was Z per unit old, right, and times SB new over SB old times B old over BV new square, right? That's what the equation, right? So I'm going to apply this equation to each of the component. For the generator, first start with the generator over here. So for the generator, we know that old base. Start with the generator over here. So generator, I know their old per unit impedance is this one right here, old per unit impedance. So that would be 0.1, right? Then I know that new base would be my base over here, which is 100 MVA. So it's 100. And old base, I know that is right here, is 80 MVA, right? So I could avoid the unit here because the same unit. Then over here, the old voltage is 100, because that's what it says over here, 100 kV, old voltage 100. So that is 100 over here. Then my new also 100, so they're the same. So then if I do the math over here, so that would be GPU new for the generator would be, let's do the math here. This one would be cancel 100 and 100, so 0.0 0.1 0.1 times 100 over 80, 0.125. So I have 0.125 per unit. So this is the new per unit impedance for the generator to the power system. Remember, the old one was 0.1, now it changed to 0.125 per unit. Then I can do it for, let's say, motor, that you can do for others too. Let's do for motor. So for motor, G per unit new would be, again, the old per unit for the motor was 0.08, right? Then over here, SB new is 100, because my base for the power system is 100. Then old one for the motor is 50 right here. The voltage now, the new old voltage for the motor was 80. So 80 over here. New one, if you look at the new one, this is the new base over here, which is the base number 4. That's the base for the motor right here. That is 100, right, squared. So now for the motor, G per unit new for the motor would be, let's say, 80 over 100 squared times 2 times 0.08 will give you 0.1024 per unit. So now this is the new per unit impedance for the motor with the power system base. So now you can do this for all other of them. Then everything will be transferred. You can do it for the transformer 1, transformer 2, and the line. Let me show you the line over here. For the line, I need to find the base for the line first. So ZB for the line. As you know, the equation is line voltage in kV, right, is line to line squared over base MVA, right? So this line voltage, if you look at the diagram over here, line voltage is 200. So I'm going to put 200 over here, squared, kilovolts squared, over base MVA is 100. So if I do the math over here now, 200 squared over 100, I get 400. So 400 ohms is my base impedance for the line. So now per unit impedance for the line would be your actual impedance. The actual impedance for the line, if you go back here, that is 100 plus J 300 right here. So 100 plus J 300 over 400, which is your base impedance. If I do the math here now, you got 0.25. 300 over 400 will give you 0.75, I guess. Let me check. This point is J 0.75. So there's no unit, it's a per unit, right? So that's your impedance for the line. So now if you put all together, I did not do transformer 1 and 2, you can do that. For the transformer 1 and 2, you can either use lower voltage side or higher voltage side, doesn't matter. You can use either side, you'll get the same answer. So now, if I put it now together here, so how does it look like? So that will look like this. See, that's your EG, transformer excitation voltage. This is your transformer impedance, and we found it. So generator impedance 0.125. So it's a J over here. So J 0.125 per unit. Then your transformer will become an impedance here. Then you also have this line here. Then transformer will become an impedance over here. Your motor will be become an impedance over here, and you have back EMF for the motor. Then you get other side over here. So this motor, we just found the motor one. Motor one is 0.1024. So is J 0.1024 per unit. Then this one I also found it. This is 0.25 plus J 0.75 per unit. You can also find these two over here. I'm gonna put JX2, JX1. So this is the power unit diagram for your system. All right, that's how you find. Then you can do all the calculation here using power unit, voltage and current. We're gonna get that into the class. Just trying to show you how you can do. So here you have your system. Then you have your original data for each of the component. Then you use the equations we develop in the class to convert those power unit, all power unit impedance value to the new power unit impedance value, that is with your power system base. Then you come back over here and redraw the diagram in per unit system. So we're gonna do another example in the class, and you will have, we're gonna do all the voltage and current calculation for the per unit system too. All right, we'll see you in the class. Bye.